It is a characteristic property of all the liquids. Like viscosity, it is associated with all the liquids, and it makes many differences in the properties of a liquid. Before moving to the details of surface tension, we must first know what actually the surface tension is and how it is generated, how this tension is generated on the surface of the liquid. Here in figure 1, we can see two types of molecules. Molecules which are present on the surface of a liquid, we can name them as X, and molecules which are present in the column or in a bulk of a liquid, we can name them as a Y. Now you see there are two types of molecules, X and Y. Those molecules which are present on the surface, they are X, and those molecules which are present in the column of the liquid and the bulk of the liquid, they will be known as Y. They both are the same molecules because they belong to the same liquid. Like if it is a water, then both the molecules would be of H2. But on the basis of the force which they are experiencing, they are different. Molecule X, it realizes force only downwards because in a bulk there are n number of molecules of water and they attract the molecule which are present on the surface. It means Y type of molecules attracts X type of molecules downwards, and these X type of molecules don't have any molecule towards their upper side. So the net force which they experience is a downward force which ultimately moves them in a bulk. But when we discuss or say about molecules Y, these molecule Y, they are surrounded from all the sides by the molecules of their type, and they experience the same force. Thus, net neutralization of the force works and they want more anywhere. So on the basis of this fact, we can say that molecules which are present on the surface of the liquid, they experience net downward force, and as a result of which they move in a liquid. So ultimately this molecule will move in a liquid bulk, thus resulting in an empty space on the surface. This empty space is responsible for generation of surface tension. How? To fulfill these empty spaces which are generated, or these voids which are generated due to the movement of the surface molecules in a bulk, the molecules which are present in the vicinity of these empty spaces stretch towards this empty space like this. Before they were like this orientation, but after movement of this downwards, there is empty space here, and to fill this, they stretch in a this way, thus making the whole surface stretched, or thus making the whole surface tense. This is the origin of surface tension. Now, secondly, we can say that the molecules which are present on the surface, they easily move in a bulk because it is a well-known concept that with increase in attraction, there would be decrease in energy, and as a result of it, there would be increase in stability. So molecules of the surface, when moves in a bulk or a column, they are going towards the site where they will experience more attractive forces, and as a result of it, they will decrease their energy more, and thus making themselves more stable. So from the surface, molecules can easily move downwards to stabilize themselves and to satisfy the force which is working downwards, thus making the surface more tense. So this is the origin of surface tension, and it works in case of all the liquids. We will discuss the dependence of various factors later on. Now here we have a relation 2 pi r gamma is equals to VdG. 2 pi r is equals to VdG means the 2 pi r gamma is a force which works upwards, and VdG is a force working downwards. We know that in a capillary, when it comes in a contact with liquid, liquid rises automatically in a capillary. Why? It is because of surface tension. How? See, in a figure 2, we have a capillary and this is a point up to which the liquid rised. 2 pi r gamma means at the circumference of this capillary, surface tension works and it carried liquids upward. But at certain point it stops, it ceases rising up. Why? It is because it rises up to a point, or it rises up to that point up to where the downward force counterbalances this 2 pi r gamma. Means when VdG is equals to 2 pi r gamma, the liquid ceases rising up. 2 pi r gamma, as said, it is 2 pi r is the circumference of capillary, gamma is the surface tension which carries liquids upwards. VdG is the volume. Volume of what? It is the volume of this column, liquid column. D is the density, the liquid which is under consideration, its density, and G is the gravity which is working downward. So we can say that VD and G, they combinedly make the total weight which acts downwards, and 2 pi r gamma which acts upwards. Liquid rises up to that point, make it a point. Liquid rises up to that point in a capillary where 2 pi r gamma becomes equals to VdG. Now, if you want to measure the surface tension of any liquid, the simplest way is to use stalagmometer. Stalagmometer, it is a glass tube where everyone knows. It is a way to measure a surface tension of any given unknown liquid relative to water. So 2 pi r gamma 1 is equals to V upon N1 into D1, and G is the total system for water, and this is for the unknown liquid. So first what we have to do is we have to suck water in a stalagmometer up to the point, and then we release it, and we have to count the number of water droplets which are generally needed to make that water level up to the lower point. So V is the volume, N1, D1 and G. When we combine this relation, it comes out to be gamma 1 upon gamma 2 is equals to N2 upon N1 into D1 upon D2. So gamma 1, it is the surface tension of water which is known. Gamma 2 we have to detect. N2, it is the number of water droplets of unknown liquid from the stalagmometer. It is the number of water droplets of water from the stalagmometer. D1 is the density of water and D2 is the density of unknown liquid. When we put the values of all these, we can easily detect the value of gamma 2. So in this way we can easily come to know about the value of surface tension in given unknown liquids. Now, what are the factors which affect surface tension? Temperature is the most important factor which affects surface tension. How? The relation is gamma is inversely proportional to temperature. It means with increase in temperature there would be decrease in surface tension. If you increase the temperature of liquid, there would be decrease in surface tension. Why it happens? Many times it happens because you see in this structure, if we start heating this liquid, with increase in heating there would be the increase in kinetic energy of these molecules, and as a result of which these molecules will become more random and they will move here and there, and finally these molecules will move towards surface of the liquid. So with elevated temperature or increased temperature, the molecules which are present on the surface, they will realize less attractive forces downwards, because the molecules which were attracting these surface molecules towards themselves, they are more random and they are moving here and there. And finally, if some molecule move in this bulk to fulfill their space, the vicinity molecules need not to stretch, but with increased temperature, the molecules which are present in the bulk, they got enough kinetic energy, and due to this, the molecules from the bulk move to fulfill these empty spaces. Thus, with increase in temperature, surface tension decreases. At the point of boiling, that is at boiling point, surface tension becomes zero. It is because What is boiling point? Boiling point is a point where the pressure of the liquid becomes equal to the atmospheric pressure. It means all the molecules which are present in the bulk, they are tremendously moving towards the surface, and as a result of which there would be no empty space on the surface, and thus making surface tension zero. So this is all about surface tension. Thank you.